reflection, we usually consider reflection from plane mirrors. The situation is slightly different when we are dealing with spherical mirrors because of the curvature of the surface. There are certain properties that we need to remember when we are dealing with spherical mirrors. Primarily, there are two types, the convex mirror and the concave mirror. A spherical mirror is any mirror which can be cut out of a hollow sphere. If you silver the outside surface of that cut section, you are getting a concave mirror. A concave mirror, you can look into a cave. That is how you remember this. On the other hand, if the inner side is silvered and the outer side is reflecting, that is a convex mirror. To understand the concepts that we have to work with here, we are going to consider the concave mirror, and we have to understand some of the terminology that we are going to use when dealing with spherical mirrors. So first of all, let's understand what are the various terms we need to use when we are dealing with this type of mirror. As I said, a spherical mirror has been cut out of a sphere. So any sphere will have a center, and in the case of spherical mirrors, we will call the center C, or the center of curvature. So the center of curvature is a point which is at the center of the imaginary sphere from which we cut this concave mirror. So the distance between the center of this mirror and the immediately opposite point on the mirror, which we call the pole, this is the radius of curvature. So here we have the radius of curvature, and this point on the mirror is the pole, denoted as P. Now, if you take a line that is extending in both directions indefinitely and is connecting the points C and P, this is what we know as the principal axis for this mirror. The principal axis is the reference point that we use for all things: the distance of the object from the mirror, the distance of the image from the mirror, the orientation of the image with respect to the object. All of these measurements are done with reference to the principal axis. Now, halfway between the center of curvature and the pole of the mirror, we have another important point of interest, and this point is what we call our focus. Now, what is important about the focus? The focus is the point where if you have a ray coming parallel to the principal axis and hitting the mirror, the focus is the point through which that ray will pass. So if I have a point here and we have a ray of light coming straight from this point, it will pass after reflection through the focus of this mirror. So this is the propagation direction for this particular ray of light. Aside from this, there are certain conventions that we need to follow when we are constructing the equations for the behavior of spherical mirrors. All the measurements are done with reference to the direction in which light is traveling. If the point is being measured on any location on the principal axis in the same direction as the direction of light, that distance is considered to be positive. So the distance being traveled from the object towards the mirror will be considered positive. On the other hand, all distances measured by starting at the mirror and going outwards will be considered negative. So a ray of light which is traveling after reflection from the mirror in this direction is traveling in the opposite direction of the incident light. So this distance is considered to be negative. Also, any distance which is going upwards from the principal axis is considered positive, and any distance going downwards from the principal axis is considered negative. This is the sign convention that we will follow for all ray diagrams for any type of mirror in this course.
Manorama Horizon. Learning made simple.